welcome back to our channel. Derivation tree or a parse tree. Derivation tree, and the same is also known as parse tree. Parse tree, right? So in this trees concept, this derivation tree consists of three nodes. So first one is a root node, or we can call it as a root vertex or root node. So which is nothing but a start symbol of our CFG, start symbol. Okay, and also this will be known as the non-terminal. Okay, non-terminal. And the second one is leaf node or leaf vertex. Leaf node or leaf vertex. That means these are nothing but terminals. Okay, and the third one is intermediate nodes. Intermediate vertex. So these are all non-terminals, a set of non-terminals other than the start symbol. Okay, these are all the non-terminals. So if you consider any context-free grammar, so is there any string which accepted by this context-free grammar can be derived by using some derivation, and that can be graphically represented by using this derivation tree, right? For example, let us take some context-free grammar. S tends to some B, S, B, or A or B. So let us take this example. Okay, and we need to construct the derivation tree for a string. B, B, A, B, B. So we need to construct the string. So construction of a string means this string is accepted by this particular context-free grammar. So we need to derive the string from this production rules. Okay, we need to derive the string from this production rules. So let us start with the start symbol S. So in S we can substitute B, S, B. So B, S, B. Okay, so the first B was done, and again S can be substituted with B, S, B. So again, once again, I will go with this one, B, S, B. Okay, so from the start symbol, we are just substituting the production rules and deriving the string, because this string is an accepted string by this particular CFG, context-free grammar. So we are supposed to derive this string from this production rules. So you can observe here B, B. So this one also achieved B, B. Okay, and also at the end we have achieved B, B. Now A. So you can also substitute S with A. So if you substitute S with A, so you can observe here. So it will be B and it will be B, and here you can observe B, 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 B. So this is the required string. Okay, this is the required string. So first of all, we have substituted B, S, B, and again in the S we are again substituting B, S, B, and in the S we are substituting A, so that we got this particular string, right? So if the string is accepted by the context-free grammar, then we can derive that string by substituting the production rules. And based upon this derivation, so this is called a derivation, right? This is called the derivation. And from this derivation, we can easily construct this derivation tree. So what is the start symbol? Root vertex. That is a start. Yes, right? This is the start symbol. And yes, by yes we are substituting the another production, that is SB, SB. So it will be having the branches B, S, B. So this is a B, S, B. So here you can observe B are nothing but a terminals. So if it is a terminal, automatically it will be the leaf vertex. So there will be no expansion, right? There will be no branches. And S is a non-terminal, so it is an intermediate. So we can expand S again, right? Again, in order to get the given string, S should be again divided into B, S, B. B, S, B. So again you can observe B are the terminals we can't expand. So these are the leaf nodes. Now again we can substitute S. So in order to get the given string, S should be substituted with A. right? Now I will expand this one with A. Now you can observe A is again this terminal, so we can't expand it one. Now just read the leaf nodes from left to right. So you can observe here. So B, B, A, B, B, right? So B, B, A, B and B. So this is the string. You got this string, right? So in order to draw the derivation tree, so it would be very easy if you derive the string from the production rules. So from this derivation, so we can simply write the derivation tree, right? So hope you understood. First we need to take the string which is accepted by the context-free grammar, and we can directly, so here the strings that are accepted by this context-free grammars will be many. So for example, if the string is B, A, B, this is also accepted string. This is also accepted string, right? So we can also draw the derivation tree for this one. So B, S, B, and here it will be A. So you can observe here B, A, B, right? So we need to read the leaf nodes from left to right in order to get the string. So here we are reading from left to right. So from leftmost. So B, A, B. So this is a string. So we can consider any string and just derive that string by applying the productions, and directly from that derivation we can simply draw the derivation tree. So we'll see one more example for this derivation tree. So consider the one more example. So this is the production rules, right? So this is the context-free grammar. So S tends to AB or epsilon, A tends to AB, and B tends to SB, and the string is here. So we need to construct the derivation tree for this one. So before constructing the derivation tree, first let us derive the string from the production rules. So I will write this one above. I think it's visible. Yes. AB or epsilon. Right. Now let me start with S. Yes. So S can be substituted with AB or epsilon. So I will just write A, B. And now first we need to get the terminal A. So in order to get the terminal, so A can be derived as A, B, B. Right? This was achieved. And again we need to get A. So in order to get A, here you just write S, B and B. So now this A is, sorry, S, A, S, B, right? And again, so if you want to get A, just we need to apply S as A, B, B, B. And again, now instead of A, so we need to get this one, right? So A, instead of A, we can write A, B, B, B and B. Right? Now, you can observe here, 2 A's have been achieved. Now we need to get a B. So instead of B here, you can write it S, B, B, B and B. Okay. So you can observe here, we have to get a B. So instead of S, we can simply apply epsilon. So this will be A, epsilon B, B, B and a B. So you can simply avoid the epsilon, A, B, capital B, small b and a capital B. And again, so this was achieved. Now again we need to get a B here. So instead of getting, if you for getting B, now again substitute this one A, B, and B can be written as SB. Again you can write SB, B and a B. Again you can apply the epsilon A, B, epsilon B, B and B. So avoid the epsilon A, B, B, B and B. Right? Again you need to expand this B. So we have achieved this one. Up to here we have done, right? Last B. So this will be done. I will write here. So A, B, B, B and B. Right? So instead of B, again I am just substituting here A, B, 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 S. Sorry, this is BS. sorry, SP. Okay, SB. So right now A B B B epsilon B. So simply we can avoid the epsilon. So simply we will get this one. So this is the string. So this string was derived from the start symbol. Okay, simply we are deriving the string from the start symbol. So just represent the same derivation using the derivation tree. So start with symbol S. Start with symbol S. Okay. So yes, first we have given A and B. Next, A is again divided into AB. So A, B, right? And again B is divided into S into B. So we need not change this one because this is a terminal, right? So S and B, right? We need to change B. Again, this S is divided as AB. So once again, A, B. Okay, and again A is divided as AB. A, B. Okay. Now again B is divided as SB. Yes, B. Right. And now see, this B is again divided as SB. Yes and B, and here we have given some epsilon. We have given some epsilon, and here also we are giving some epsilon, and you can see A, B, 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 and here again B is divided as S and B, which is nothing but epsilon here. So this is the derivation tree for this particular context-free grammar to achieve the string for 2 A's followed by 4 B's. So you have to read the string from left to right, all the leaf nodes from left to right. See, A, and what is the next one? A, what is the next one? Epsilon, B, 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 epsilon, B, right? So A, epsilon, B, epsilon, B, B, epsilon, B. So from reading from left to right, we are achieving this particular string. So this process we call it as a derivation tree. So this is called a derivation, and this is the derivation tree. So if you derive the string from the production rules, then it will be very easy to draw the derivation tree, and this derivation tree is also known as parse tree. Parse tree. Okay, derivation tree or a parse tree. So 3 nodes will be there. One is a root node, another one is a leaf node, another one is an intermediate node. So root node is a start symbol, leaf nodes are terminals, and intermediate nodes are non-terminals. Right? So hope you understood this derivation tree and the derivation. So leftmost derivation tree and the rightmost derivation tree. So in the previous session we have discussed about the derivation tree or a parse tree. So where we have to derive the string from the production rules. And in that we are just substituting the production rules to get the required string. And we have constructed the parse tree or derivation tree. So there we have seen the 3 vertex, that is a root vertex, and the leaf vertex or the intermediate vertex. And the string will be completely with the terminals. And by using the production rules, we are supposed to derive the complete string. And today we will go with the left derivation tree and right derivation tree. So simply I will write it as a types of a derivation tree. Types of a derivation tree. So here it is a leftmost derivation tree and rightmost derivation tree. Right, 2 types of derivations. So what is the difference between these things, rightmost and leftmost? So if you are deriving or constructing the derivation tree, we are supposed to substitute the production rules, right, one by one. Now in the leftmost derivation tree, the derivation will be done derivation will be done from leftmost non-terminal in production rule, right? So I will tell you an example, so don't worry. So the derivation will be done from leftmost, right? We need to substitute the production rules from the leftmost non-terminals. And coming to the rightmost, so the same, the derivation will be done from rightmost non-terminal in production rule, right? So we are moving from leftmost non-terminal to the terminals, and here we will move with the rightmost. Example, let us take the productions. E tends to E plus E, and again E tends to E into E, where E tends to A or B or C. Okay, so this is the example. So we need to construct the rightmost derivation tree and the leftmost derivation tree for this particular grammar. And here the terminals are the terminals are plus star A, B and C. All these are the terminals. And non-terminals are E. Okay, only one non-terminal, that is E. So let us let us derive the thing. Okay, first let us derive the string. So for example, the string is A plus B into C. So this is the string. So we need to derive this string from this particular grammar. Now we'll see. I will start with E because E is a start symbol. So here we need to go from the leftmost. So E can be substituted with this production or this production, right? So I will go with this production. So E can be substituted with E plus E. Okay. So here we have to derive the string from the leftmost. So in this production or in this expression, we have to first substitute with the leftmost. So what is the leftmost? Here E is the leftmost. So first we need to substitute the production for E and then this E, because this is the leftmost. Okay. Now leftmost E, according to the given string, first one is A. Okay, A plus B into C. So this I will replace with A plus E. Now you can observe the leftmost non-terminal. So here the leftmost non-terminal is this one. Okay, previously we are having two non-terminals. Among these two non-terminals, the leftmost non-terminal is this one. So first we need to substitute this one. And the next, after getting the result, now again check for the leftmost non-terminal. So this is the leftmost non-terminal. Now according to the string B into C, so this will be given as A plus E into E. So I will substitute E into E. Now among these, what is the leftmost? What is the leftmost? So this is the leftmost. Now replace this E with B into E. Again, from this, what is the leftmost? This one is the leftmost because only one non-terminal is there, right? So A plus B into, what's the E value here? C. C is a non-terminal, right? So we have derived the given string. From the leftmost non-terminal. Okay, by substituting the leftmost non-terminals. Now coming to the rightmost non-terminal, so take the same thing. So E. So I will substitute the same production here. E plus E. E plus E. Now, what we have to do? We have to derive the given string from the rightmost non-terminal. So among these two, what is the rightmost? This one is the rightmost. First, I have to substitute this one. So E plus, what we have to get? B into C. That means we can take this production E into E. So E into E. Now, so what is the next thing? Again, we are having some three non-terminals, right? Three non-terminals. Among these three non-terminals, we have to substitute the terminal. We have to substitute the non-terminal from the rightmost. So what is the rightmost non-terminal? This one. So just give here C into E plus E. Right? Now among these two, what is the next non-terminal? Rightmost. Rightmost means this one. So substitute here B into C plus E. Now what is the rightmost non-terminal? Only one terminal is here. So we can substitute here A plus B into C. So you can observe here, we have derived the same thing. By using the rightmost derivation tree. Okay, by rightmost derivation. So here we are deriving the string from the leftmost non-terminals, and here we are deriving the string from the rightmost non-terminal. So simply you can draw the tree. So E is a start symbol, that is a root vertex. From this we have divided into E plus E. Okay, and again we have derived the leftmost, right? So here we have given A, right? And this one we have derived again E into E. Now among this one, again we have to derive this one B, and here it is C. Now read the leaves from the left to right. So A plus B into C. So automatically we got this tree. Now just draw the tree for this. So I am taking E, and from E it was derived E plus E, and now rightmost. Okay, rightmost means this one. So again I have derived from here E star E, and now you can see this one a C, this one a B, and this one A. So even though both trees are common, so we have derived the string from the rightmost non-terminal here and from the leftmost non-terminal here. So here also you can observe here, just read the leaves from left to right, A plus B star C. Right? So in both the cases we are getting the string. We are deriving the string, but only the difference is we are applying the production rules, substituting the production rules from the leftmost non-terminal and here from the rightmost non-terminal. Right? So hope you understood this one. Let us move on with the next second example, and so that if you are still having any doubts, so it will be clarified. Now let us see the second example. So let us take this grammar, and the string is this one. So we will derive that string from the leftmost derivation using the rightmost derivation. So if you derive the string, automatically we can simply draw the diagram, right? So let us see the derivation first. Okay, after that you can simply construct the derivation tree. So let us take the leftmost derivation first. It will start with S. Okay, so S can be substituted with T 0 0 T. So here the terminals are 0 and 1. Terminals are 0 and 1, and non-terminals are S and T. Non-terminals are S and T. So we need to derive this string. Okay, we need to derive this string. First, let me consider S. I will start with the start symbol S, and S is substituted with the T 0 0 T. Right? Now, first in the string, first symbol is 1. So you can replace. So it will be derived from the leftmost. Okay, leftmost means this one. First we need to derive this one. So we can apply T with 1T because the string starts with 1. So 1T 0 0 T. And now here you can observe, now from these two non-terminals, what is the leftmost? So this T. Now you can observe this one. So first one, next one, it is 0. So we can replace the T with 0T 0 0 T. Okay. Now see, in our string there is a 3 zeros. So you have to substitute T so that we have to get the resultant 3 zeros. So automatically we can simply apply this epsilon. So this T is replaced with epsilon, right? So because this is the leftmost non-terminal in the given string. So 1 0 epsilon 0 0 T. So this can be written as 1 0 0 T. Now among this one, only one non-terminal is there, this one. Now what is the result? The next one is 1. So this will be substituted with 1T. So that 1 0 0 0 1T. Again, we need to get 1. So again, this will be substituted with 1, 0, 0, 1, 1 t. Again, we need to get one more t. So again, this can be written as 1, 0, 0, 1, 1, 1 t. Now you can observe here the complete string was achieved. 1, 0, 0, 0, 1, 1, 0, 0, 0, 1. Now simply replace this t with the epsilon, so that 1, 0, 0, 0, 1, 1, 1 epsilon. So finally we will get the result 1, 0, 0, 0, 1, 1, 1. So this is the required string. So we are deriving this particular string, okay, we are deriving this particular string by applying the leftmost derivation. So we are just substituting the non-terminals which are on the leftmost, okay, in the string. Now the same thing we can derive by using the rightmost. So let us start with the S and E. In the S we can represent T, 0, 0 T, because there is no option, right? Only one production is there. Here among these two non-terminals, so as it is a rightmost derivation, we have to consider the rightmost non-terminal. So because this one, we need to consider this one, right? We need to consider this one. So you can simply use C, 0, 0, okay. So in the string, you can observe here, there is a 0, 0. So 0, 0 is there. So we need to get one more 0. So simply you can go with a 0 T, okay. So T, 0, 0, 0 T. T, 0, 0, 0 T. So among these two non-terminals, again this one, we need to create this one. So this can be replaced with 0, 0, 0, and next one is 1. So 1 T. So T, 0, 0, 0, okay, and this T can be again considered as 1 T because another one is there. And again, rightmost, we are deriving the rightmost, right? Again, you need to consider this one, and T, 0, 0, 0, 1, 1, 1 T. Now you can observe here, so the string is ended with the 3 ones. So here also the string ends with 3 ones. So simply you can apply the epsilon here, so that we will get T, 0, 0, 1, 1, 1 epsilon. So which is nothing but T, 0, 0, 0, 1. So now there is no rightmost terminal. So there are no more than one non-terminal, right? It is having only one non-terminal. So we need to substitute this one. So the string will start with 1. So simply replace T with 1 T, 0, 0, 0, 1, 1, 1. And you can observe here the string is 1 followed by 3 zeros and 3 ones. And here 1 followed by 3 zeros and 3 ones. There is an extra non-terminal. So simply you can replace this T with the epsilon. So the T with the epsilon, 1 epsilon, 0, 0, 0, 1, 1, 1. So simply the result is 1 followed by 3 zeros and 3 ones. So we have generated this string, we have derived this string, required string, using the rightmost derivation, So here we are deriving the string from the leftmost derivation. That means substituting the leftmost non-terminals. Here we are applying from the rightmost non-terminals. Right? So hope you understood. So from this derivation you can simply draw the diagram. That means a tree. Okay, so hope you understood this one. If you are having any doubts regarding this leftmost derivation and the rightmost derivation, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.